For decades, artificial intelligence functioned as a straightforward tool. You gave it a defined input, and it returned a calculated output. Modern large language models operate differently. They function as open-ended, collaborative thought partners. Because they converse fluidly in natural language, LLMs project an illusion of universal competence. A model that writes brilliant code might offer terrible legal advice with the exact same authoritative tone, masking severe inconsistencies depending on the domain. This brings us to a specific, measurable danger: over-reliance. It is crucial to define this not as a feeling, but as a behavior. Trust is your internal psychological state. Over-reliance is the physical act of uncritical delegation, adopting a system's output when it is wrong, or letting it make a decision you should be making yourself. You can fail at human-machine interaction in two opposite directions. On one end is algorithm aversion, where you ignore accurate recommendations out of distrust. On the other is over-reliance. Over-reliance is uniquely insidious because it usually happens completely unintentionally. You do not set out to offload your responsibility, you just slip into it. Conversational design actively compels users to bypass their own critical oversight. This translates misplaced trust directly into behavioral errors, irrespective of whether the underlying model is hallucinating. We can track these errors playing out right now. In high-stakes fields like law and medicine, professionals are generating immediate, short-term errors. Lawyers have submitted court briefs containing entirely fabricated case citations generated by AI. The text sounds plausible, so users rely on it without verifying facts. These individual failures quickly scale into institutional liabilities. When hospitals or corporate departments restructure their daily workflows around unverified AI outputs, they reduce human oversight and expose the entire organization to cascading operational vulnerabilities. Over a longer timeline, the risk shifts from immediate errors to cognitive deskilling. When users chronically depend on an AI system to do their thinking, they slowly lose both the skill and the motivation for independent problem-solving. At a macro scale, we see the rise of algorithmic monocultures. When multiple institutions rely on the same language models, their decision-making begins to homogenize. If thousands of traders react to the same misinterpreted AI analysis simultaneously, the resulting synchronized action creates a systemic vulnerability that can destabilize entire markets. The tech industry and academic researchers are largely blind to the true scale of these harms. Our historical scientific paradigms for measuring how humans rely on AI are broken. For decades, human-computer interaction studies relied on a standard model called the Judge-Advisor framework. Researchers measured two metrics. First, advice acceptance. Did the human take the AI's answer? Second, switch fraction. How often did the human change to match the machine? This framework requires two strict conditions: discrete decision points, a clear moment where advice is accepted or rejected, and an objective ground truth to measure against. Conversational language models completely shatter the assumption of a discrete decision point. Using an LLM involves continuous back-and-forth dialogue. You prompt, the model replies. You refine, the model adjusts. Because influence happens gradually over multiple turns, it is impossible to pinpoint the exact source of an idea or calculate a clean switch fraction. We are attempting to measure continuous collaboration with a binary ruler. Applying simple yes or no metrics to fluid, multi-turn interactions results in useless data. This diagram outlines three specific characteristics of modern language models that break traditional measurement. The first is interactive use. The continuous dialogue removes the clear decision boundaries required by legacy metrics. The second challenge is complex text-based outputs. Older AI predicted a discrete label, like identifying an image as a cat or a dog. Language models output complex, multi-layered paragraphs. This means reliance is no longer an all-or-nothing choice. The unit of reliance is granular. A user might adopt the overarching thematic direction of a generated essay, but manually rewrite specific factual claims inside it. You cannot evaluate a text generation using a binary agreement metric when the user engages with different components of that text at varying levels of trust and critical evaluation. Finally, the third breakdown is the general-purpose nature of the models. We use these systems for factual retrieval, but also for creative strategy, personal advice, and emotional support. These subjective domains lack established benchmarks for a correct answer. Because LLM outputs are continuous, multi-layered, and often operate in areas without an objective ground truth, attempting to calculate appropriate reliance by checking the final text for accuracy is a scientific dead end. Even if we could measure reliance perfectly, we must understand why we over-rely in the first place. Humans operate under strict cognitive capacity constraints. To budget our mental effort, we use resource-rational analyses, constantly calculating when to think deeply and when to take shortcuts. Language models hijack this mental budget through expert mimicry. By utilizing structured formatting, citations, and an unfailingly confident tone, they signal high epistemic reliability. They convince our brains that deep critical evaluation isn't worth the calorie expenditure. This is compounded by sycophancy. During their training, these models learn to be highly agreeable, deliberately tailoring their outputs to align with the user's existing beliefs. When a machine tells you exactly what you already suspect is true, it creates a powerful negative feedback loop. Your biases are validated, extinguishing the motivation to scrutinize the output. The interface weaponizes our own cognitive biases. By defaulting to highly fluent, confident, and sycophantic language, the system signals that human oversight is unnecessary. The user adopts the output before they even realize a decision has been delegated. To fix this, we must evaluate human-AI interaction using the 3 directions shown on the right. First, go beyond single-point measures. Instead of binary agreement, track exactly how many tokens are kept or modified. Second, shift focus from text outputs to final outcomes. Outcome-based measurement judges appropriate reliance by tracking the user's actual success. Did they achieve their overarching goal without degrading their own well-being or capability? The intermediate text generated along the way matters less than the end result of the collaboration. Only by implementing this kind of holistic, outcome-based tracking will researchers gather the precise behavioral data necessary to build effective mitigation strategies. Once measured, we can engineer skepticism into the interface using a 3-layered approach. At the foundational model layer, reward functions must be recalibrated to penalize unwarranted certainty, stopping the model from presenting subjective information as absolute fact. Models need to be explicitly trained to utilize natural language epistemic markers. If the system is unsure, it needs to explicitly state, "I am not sure, but," to help users accurately calibrate their reliance. Moving up to the system layer, we address the interface. Here, developers implement cognitive forcing functions. By adding frictions, like requiring a confirmation click or alternative predictions, the interface breaks automatic processing, forcing the user to evaluate data. Finally, at the top user layer, we deploy AI literacy interventions. We must aggressively correct miscalibrated expectations, ensuring users understand the underlying hallucination rates and true capabilities of the tools they use. Solving over-reliance is a structural redesign, requiring aligned interventions across the model's weights, the system's interface, and the user's mental model. A common counterargument suggests that as AI reaches superhuman performance, over-reliance will cease to be a problem because the machines will simply stop making mistakes. This ignores the paradox of capability. As systems become more sophisticated and fluent, the few errors they do make become exponentially more difficult to detect. We will always require human oversight for legal and societal accountability. Because of this, advancing AI capabilities makes measuring and mitigating over-reliance more essential, not less. If we fail to redesign our metrics and engineer appropriate friction, we risk building technologies that slowly erode human autonomy. We must ensure these tools support our capabilities rather than replacing them.